In this video, we are going to be looking at more examples of u-substitution. Our first example is going to be to find the antiderivative of x squared times e to the x cubed plus 5 dx. And I want to first of all analyze the problem. When I look at what the integrand is, I notice that there is a composition here. We have e to the junk, and the junk happens to have a derivative that involves an x squared. And because of that, it is reasonable to let u be the junk. In other words, u is going to be x cubed plus 5. du dx then is 3x squared, and so when we convert to differential notation, we have du is equal to 3x squared dx. And I'm going to use this particular information to rewrite my integral. Now, the first thing that I want to notice is that I am missing this 3. And I patch the integral up by multiplying it by a fancy name for 1, namely 3 over 3. And so I'm going to write this integral as 3 over 3 times the integral of x squared times e to the x cubed plus 5 dx. And now what I want to do is I'm going to circle the things that make up the du. This 3 combined with that x squared, combined with the dx, form the du. And so when I do the u-substitution, what I have is 1/3 times the integral of e to the u du. Because this chunk here, of course, is a u. And I know how to integrate the integral of e to the u du. That's simply going to be 1/3 times e to the u plus a constant. And then to get my final answer, all I have to do is substitute the x cubed plus 5 back in for the u. And when I do that, I get my final answer of 1/3 times e to the x cubed plus 5 plus whatever constant I want to add. So let's look at another example. This example, I want to find the antiderivative of, let's make it the sine of x times the cosine of x dx. Now, this is kind of a strange looking thing, but what again I want to do is I want to realize that the cosine of the cosine is indeed a composition. And the inside function is cosine x, and the derivative of cosine x happens to be minus the sine of x, and there's the sine of x, and since minus the sine of x is just -1 times sine x, I can patch this one up. In other words, it is reasonable to let u be cosine of x. Du dx then is minus the sine of x. So du is going to be minus the sine of x dx. And I'm going to use this information to rewrite my integral as follows. So we're going to rewrite this integral as, first of all, I'm going to do -1 times -1, because that's just a fancy name for 1, times the integral of the sine of x times cosine of x dx. And now what I want to do is I want to find the things that make up the du. I need one of these negative signs, I need the sine of x, and I need the dx. Those 3 things go together and form the du. And when I realize that, what I'm left with is an integral that is -1 times the integral of the cosine of u, actually that should be a yellow parenthesis, and then du. Because all I did was I substituted the du for the circled things, and this thing here is cosine of u. I know what the antiderivative of cosine of u is. We're going to get that negative 1 times the sine of u plus a constant. And so our final answer is going to be minus the sine of u, which is cosine of x, plus any constant that I want to add. Well, let's do another example. So this example, I'm going to have something like the antiderivative of, let's make it x to the fourth over 5x to the fifth plus 17 dx. Now this one is just a little bit trickier in that it may be a little bit difficult to see that there is a composition involved. So the first thing that I'm going to do is I'm going to realize that we've got a top and a bottom, and the derivative of the bottom involves an x to the fourth, which is sitting up there. So I'm going to rewrite this integral very slightly to make it easier to see that there is indeed a composition running around. I'm going to write it as 1 over the denominator times that x to the fourth times a dx. And now I can see that this part here is a composition. It's 1 over the junk, and the derivative of the junk involves an x to the fourth. So that tells me that it is reasonable to let u be equal to 5x to the fifth plus 17. du dx is going to be 25, that being correct my handwriting there, it's going to be 25x to the fourth, and so du is going to be 25x to the fourth dx. I'm missing this 25, but I can patch the integral up because that's a constant, and I patch the integral up in the following way. I'm going to write that integral as 25 divided by 25 times the integral that I was looking at, and now I'm going to circle that 25, that x to the fourth, and this dx, and they're going to form my du. And what I've got left then is 1 over 25 times the integral of 1 over u times du. And I know how to do that particular integral. That's just going to go back to 1 over 25 times the log of u plus a constant. And so the final answer is going to be 1 over 25 times the log of u, and the log of u was 5x to the fifth plus 17. Plus we have that constant of integration. Well, let's do one more example. Our last example is going to be something like this. We're going to have, let's make it, let's make it x to the 1/2 times 5x to the 3/2 plus 9 raised to the 15th. Now, what I want to notice is, again, there's an obvious composition, junk to the 15. And when I think about differentiating this junk, the derivative of an x to the 3/2 is a 3/2 times an x to the 1/2. And there's my x to the 1/2. So it is reasonable to try u is equal to the junk, which is 5x to the 3/2 plus that 9. du dx then is going to be 15/2 x to the 1/2. And so du is going to be 15/2 times x to the 1/2 dx. Now the constant here is a little bit trickier than the previous constants because we've got a 15 halves that we need to get into the integral, but it's done in the same kind of way. This integral can be thought of as 15 halves divided by 15 halves times the integral, because 15 halves divided by 15 halves is just a fancy name for 1. Now what I want to do is I want to circle the things that go into the du. And the du is going to be this top 15 halves, that x to the 1/2, and the dx. Those things together make up the du. And what's left over is 1 over 15 halves times the integral of u to the 15 du. And let me be consistent and make that du the same color as the u. And I know how to integrate u to the 15th du. So we're going to have, as the next step, well, 1 over 15 halves is the same as 2 15ths, because that's just an invert and multiply. And the antiderivative of u to the 15th is u to the 16th over 16, plus I can add any constant that I want to add. Now it's important to realize that I could either multiply that constant by this number or I can add the constant after I find the antiderivative. It's traditional not to have the constant multiplied by this multiplicative constant. And so I want to clean my answer up. This is now, let's see, that will cancel and give me a 1/8. And so we have 1 over 8 times 15 times u, which is 5x to the 3 halves, plus 9, plus that constant. And let's see, 8 times 15 is going to be, let's see, 8 times 5 is 40, and then I've got that. That's going to be 120. So we get as our final answer 1 over 120 times 5x to the 3 halves plus 9 plus a constant.